Hi, and welcome to ProTuto channel. Today I want to show you a new tutorial, the first video in the playlist named Schneider Pack Tutorials. The first tutorial will be about how to configure M580 to communicate with SCADA through OPC UA. The keywords used in this tutorial: CPU Schneider M580, Module Schneider BMENUA0100, SCADA, Schneider EcoStruxure Control Expert, UA Expert Software. So what is the topic of this video? Both CPU M580 and SCADA want to communicate with each other and exchange data. For example, we have 6 variables that CPU want to share it with SCADA. So, when we talk about exchanging data, we should talk about common communication protocol, so that both devices can talk the same language. So here, which protocol should we use? Knowing that the CPU M580 supports Modbus server or client, Ethernet IP, scanner or adapter, but with OPC UA, M580 can be only OPC UA client and not a server. And why OPC UA? Because it is one of the most important communication standards for Industry 4.0 and the IoT. With OPC, access to machines, devices, and other systems in the industrial environment is standardized and enables similar and manufacturer-independent data exchange, and in addition, the OPC UA is a secured protocol. So, what is the solution? We can add, between the CPU and SCADA, a Schneider module, named BMENUA0100. His main role is OPC UA server. So, this module will access to PLC data through the backplane, through UMAs, and then expose this data to SCADA, through OPC UA protocol. Knowing that PLC data are grouped in a database, called Data Dictionary. Also, the BMENUA module has 2 Ethernet ports, one on the backplane, the other is on the front port. So, it accesses to Data Dictionary through its backplane port, and then communicate with SCADA through its front port. Typically, SCADA, or control network, should be separated from CPU, or device network, for security reasons. That's why, the 2 Ethernet ports of the NUA module are not in the same range. For example, the backplane IP is in the range of 169.20, and the control port IP is in the range of 172.20. In this tutorial, we will assume that the BMENUA0100 module is in standard mode, or, if it is in secure mode, we have the service forwarding all is enabled, and also the service IPsec is turned off. After this introduction, let's move on to the tutorial. First of all, we will create the project in Control Expert and create the variables. Then, we will connect SCADA to M580 through NUA module in standard mode. And finally, connect SCADA to M580 through NUA module in secure mode. Following the first step, creating a project in Control Expert, we should have a M580 CPU, and then a BMENUA0100 module. As you can see, this is my configuration. I have added 2 NUA modules. I will use the first in standard mode and no secure communication with SCADA, the second in secure mode and secure communication with SCADA. If you want to add a new BMENUA module, you can find it under the menu, Communication. For the M580 CPU, I double-click on its Ethernet port and then I show you its actual address. The network range of CPU is called Device Network. The CPU IP address in this tutorial is 169.20.0.1. Then, for the first BMENUA module, here is its properties. As you can see, the module can have 2 IP addresses, one for its backplane, and the other for the front port. Knowing that, you can disable the front port and use only its backplane port. In this case, both CPU and SCADA will be in the same range. It is not recommended, but you still can proceed. In this tutorial, we will use both backplane and front port for the 2 NUA modules, as it is recommended and it is a typical configuration. You already noticed that backplane and front port IP addresses are not in the same range, as we explained before. Then, I create 6 variables, and then I create a section to animate it, since it is just a tutorial and I don't have a running process, 2 variables for measuring temperature, 2 variables for measuring press-ion, 2 variables for measuring motor set point and actual speed. I want these variables will be shared with SCADA. Also, I created an operator screen to show the actual values of the variables. As you can see, the values are already changing. To be able to share any variables with SCADA, you should first of all enable an option in project settings. This option is called Data DIC. With this option disabled, you cannot share the CPU variables with any device in the network. So, I already checked this box and enabled variables sharing with other devices, like SCADA. We finished with the first step. The CPU program is ready, and let's move on to the next step. Connect SCADA with CPU through NUA module in standard mode. This is the Software UA Expert. It can be considered as a SCADA. It is very useful as a SCADA simulator to check the well-establishment of communication with CPU, and also to check if variables are well exchanged. First of all, we will add the new OPC UA server. In our case, it is the first NUA module IP address, in standard mode. With OPC UA protocol, the server address is called endpoint URL, and it is written through this manner. opc.tcp//, then server IP address, 2 points, then the server OPC UA port number. In our case, the endpoint URL will be opc.tcp//172.20.0.4, 2 points, 4840. The 4840 is the default OPC UA port number. You can change through the properties of the module in Control Expert. After inserting the endpoint URL, UA Expert will try to discover the OPC UA server, and when it finds it, it will display it below. We can see that the NUA server is here. We click OK and we move on to the next step. Click on Connect, so that UA Expert will create a connection with the OPC UA server. Here are the data received from the OPC UA server, and we can see the name of our current application in Control Expert. Through this folder, we should find all the variable already exposed by the NUA module. Double-click on this folder, and below we find the 6 variables. These are all the variables that we created in our application. Select all, then drag and drop it here, so that we can see the details, and also, its current values. We can be sure that server is updating variables values in real time. We can also compare it with the values shown in Control Expert. We can also check the read-write mode of all the variables, so even SCADA can force values that subsequently will be taken into account by the M580 CPU. Now, let's take a look at the web page of the NUA module. We already said that the first module is in standard mode, means the communication between SCADA is not secured. To access web page, we should enter installer as username, and installer1 as password. Through the web page, we can access to all informations about the OPC UA server, BMENUA module, for example, data dictionary is turned on or off, we are in standard or secure mode, how many OPC UA clients are connected, and so on. We notice here that message security mode is set to none, means the OPC UA communication with clients is now secure. Before moving to the next step, I want to show you an option in Control Expert that is very useful and important. If you enable the option Data DIC, as we already said, you will share all the PLC variables to other devices in the network, but, what if we want to share only some variables and not all? In this case, Control Expert have an option with the name of Only HMI Variables. When you activate this option, you can after that choose which variable will be shared and which ones not. After activating this option, the next step is to select which variables we want to share. You must select it one by one, and in our case, we want to share 4 variables over 6 in total, but we want to hide the 2 variables, temperature tank 1 and 2 from SCADA, so we deselect the option, HMI variable. Once the modifications are done, we can build the changes, and then we will check these variables in SCADA. When you do a change in your PLC program, in SCADA you should click on Rebrowse, so that UA Expert will update the display of variables. As you can see, the two variables that we deselected from SCADA are already deleted from server and the client here cannot access it. Only variables we selected are shown here. Now, let's move to the third and final step, connect SCADA with M580 through NUA module in secure mode. And before we begin, we are going to delete the actual server from UA Expert and start from scratch. The second NUA module has the control port IP address 172.20.03, as we can see it through its properties. So in UA Expert, as usual, we should enter the endpoint URL and use this IP address. So first of all, we enter the endpoint URL. Then, in the menu Advanced, copy and paste the same URL. After that, we enter in the NUA web page as admin since it is in secure mode, and we should check some settings. For the password, when you reset the module and then choose the secure mode, use the default password, and then you are asked to enter a new one. The first thing to check, in the menu Cybersecurity Setup, is the OPC UA security settings. We will start with No Security. Then, as we said in the introduction, we assume that service forwarding service is set to All, and IPsec service is set to Off. After checking these settings, now we will test the communication between UA Expert and NUA module. We will click on Connect and see the result. As you can see, we succeeded in creating the connection between SCADA and M580 through NUA module, but the connection is not yet secured. To more secure the connection, we go back to the web page, and under Cybersecurity Settings Setup menu, then OPC UA menu, we will change Message Security Mode from None to Sign and Encrypt, then we choose a security policy, and finally we can select Anonymous as user identifier token type. But in this case, and when the connection is set to secure, both NUA module and SCADA, or UA Expert in our case, both devices should exchange certificates, so that they can next establish a secure connection and exchange data. When we go back to UA Expert, we notice that the connection with OPC UA server is lost, since we changed the connection settings from No Secure to Secure. Right-click on the server, select Properties, and then change the parameters the same way we did with the server, otherwise, the connection cannot be established. Both server and client should have the same security settings. When we click on OK, and we try to connect to the server, a pop-up will appear. SCADA needs you to approve the NUA server certificate. So, click on Trust Server Certificate. On the other hand, the NUA server should also trust the SCADA certificate, and to do this, go back to the web page, select the menu, Certificate Management, and then Trust List Management menu. Here, the server should have the list of certificates that it will trust and can communicate with. To select the path of the UA Expert certificate, go to the menu, Settings, Manage Certificates, and then click on Open Certificate Location. Copy the path. Going back to the NUA web page, click on Add, and select the path of SCADA certificate and add it. Through this way, both devices trust their certificates and are able to establish a secure communication and exchange data. Click on Submit, then Apply. Finally, going back to UA Expert, now we can be sure that we successfully established a secure OPC UA connection between M580 and SCADA through BMENUA0100 Module. Before finishing this tutorial, I like to share with you two important things. 1. NUA module supports only IPv4 protocol in its backplane port, but for its front port, it supports both IPv4 and IPv6. So, with front port disabled, the endpoint URL used by SCADA will be only the IP address of its backplane port. Now, with front port enabled and only IPv4 used, the The unique URL will be the IPv4 address of the front port. Finally, when IPv6 is activated for front port, so SCADA can use 3 URL. Backplane IPv4 address, front port IPv4 address, and finally, front port IPv6 address. The second thing I want to show it to you is that the NUA module can be used in standard or secure mode. If you want to change the mode, remove the module, and you can use the rotary switch located on the rear, like shown in the screenshot below. I wish you enjoyed this tutorial. Feel free to add your comments below, like and subscribe, and stay tuned for the next videos. Thanks for watching.